Good morning and welcome to Fission's Tech Talk Thursdays. It doesn't have a name other than Tech Talk Thursdays, unless James wants me to say the Fission Audio-Visual Experience. We're here with James Little as our presenter today. James, give us a wave.
Hey.
Great, thank you. He's dialing in from San Francisco and is going to talk to us about Stork, which is a search engine for static sites that's extremely fast. So really looking forward to this. So over to you, James. Feel free to ask questions as we go.
Cool. I'm going to share my screen. I put together some slides, and I'm hoping that this process doesn't take too long, even though I'm being prompted to do some Mac OS. Oh no, I have to quit out of Zoom and reopen. So I think that's what I'll do. I will leave and then come back immediately.
Yeah, no worries.
Apologies for that. All right, I will be back shortly.
Okay, what do we got? We got a pun, we got a dad joke, we got a interesting factoid of the day. I can play 80s music again. There's a link in the chat, Brian. I was quickly trying to find 80s music on request by James, so we don't quite have our audio game down, but we'll get there.
Cool. I think I'm back successfully. And let me get back to Keynote. Wonderful. Cool. So you can see the slide. I guess let me know if you can't. But yeah, so thank you very much for having me. I am really, really excited to be here to talk about Stork, which is a side project that I've been working on for about a year, a little more at this point. It's an open source tool for adding interactive full text search interfaces to the web. So if you're building a website, it needs a search box. The goal is that Stork sort of becomes the obvious tool for you to use. And I'm going to talk today about sort of the impetus for creating it, what makes it different from other things that are out there. I'll go into the internals, and then at the end, I'll talk a little bit about sort of where I see Stork going in the future, or what can come of it. But first, I want to tell you about me. Who am I? I work at Stripe in San Francisco on the Stripe terminal team, which is the in-person payments solution. I do iOS and web for them. I have a website, I have a Twitter, but sort of beyond that, I was on the staff of the college newspaper when I went to school. I ended up doing graphic design and ultimately rebuilt their website from a custom CMS to a WordPress thing. But for my whole life, I've been fairly obsessed with the web as a document and application platform. Building websites has always been like my pathway into computer science. That's how I got started. That's sort of what I like to build is cool new web experiences and watching how people are using the web as a publishing platform. When I was on the staff of the college newspaper, I spent a lot of time in this room putting together that website. This was the house on campus that we would put everything together. It was published every Friday, so Thursday night until like 4 or 5, 6 a.m. We would be like frantically working away in this house. And I did a lot of WordPress development in this room. And for a few weeks, as I was building this website, I ended up thinking a lot about the search box on the page. And I didn't realize it when I started, but I came to quickly realize that the search box on this website was one of the most essential features that it could have. Reporters would use it for finding articles about an event that had happened in the past so that they can write about it today. Students and faculty and community members would just like use the search to find articles. And we spent a lot of time trying to figure out something that would work. So we looked at things like Algolia. We looked at making the custom or the WordPress search like work well for us. And we realized that search is only a solved problem if you're willing to run a search API over HTTP so run a server or have someone else run a server for you. And there are a few problems with servers that I sort of came to realize along the way. The first is that maintenance is sort of just difficult. If you're a bunch of college students interested in journalism, you don't really care about like tweaking your Ubuntu setup or even things like dealing with Heroku application code. So maintenance is difficult. It's also introducing another point or another failure point in the system of this website. If you have to think about your search server as well as your web server, that's just another thing that can go down, another thing that people have to think about. And if you don't want to deal with that and you want to farm it off to some third-party service, that can get expensive. Usually those third-party services are built for like the corporate use case. And there wasn't really something that I found that could work well for this college newspaper, which had no money and wasn't like trying to search through something that's Google scale or a tenth of Google scale. So what we ultimately did was stick a Google custom search iframe on the page and shipped it. And it's kind of ugly and it isn't responsive at all, but it works. And it works because it's really easy. There's no configuration. There's no manual upload your articles process. Google sort of just indexes everything that we publish on the website. And it is really easy to understand how it works since it all lives in the front end code. It's just an iframe. And I shipped that and we moved on and we never ended up changing that. But I kept on thinking about this problem and realized that I had a few realizations about this style of website that I'm working on as I was trying to build a search bar. The first is that content updates once a week. That's pretty infrequently. Publish on Friday, upload all of the articles on Thursday night. The other thing is that there's a finite amount of keywords. You're only publishing a few articles a week. All of those articles are sort of about similar things. So you can imagine like a search or a lot of articles are about some sort of campus thing. And there's no institutional knowledge for the people who are actually building this website. I graduated. The people who are working on it now certainly wouldn't be able to have all of the context surrounding something really, really complicated that I built. And I sort of started wondering, there are a lot of sites that fit this description. And I wondered if they're struggling with search too. And that question kind of nibbled away at me, and I didn't do anything about it for a while, but a few things happened at the same time. So the first is that WebAssembly became easier to work with. It became an easy compilation target for languages like Rust and like Go. And people started talking about it as browsers started being able to use it and things like that. Netlify grew in popularity, which introduced the free tier for CDNs. I think Netlify is the company that really did this. CDNs were previously like something that you would build or farm out if you're a big company serving hundreds and thousands of images, but Netlify sort of made CDNs available to a bunch of people for no money. And then I listened to a podcast episode one day about how somebody else implemented full text search and realized that full text search algorithms don't have to be something that you like have to get a PhD in order to build. It's not impossible. It's not like this computer science algorithmic intense problem. If this guy on the podcast could build it, there didn't really seem to be much of a reason why I couldn't. And so just over a year ago, everything sort of came together. And this was the big idea. I can generate for a given website, I can generate a search index out of band. So when you build a static site or on a cron job for this college newspaper website, and treat these search index like a file, like a resource that has basically pre-computed every search query that someone could come up with. And pre-compute all of the results for those queries. Since the corpus for a lot of these websites isn't that big. And then I can load it onto a web page like an image, then use WebAssembly to run the search. And WebAssembly sort of became an important part because I wanted it to be fast. I wanted people to be able to take advantage of this up and coming web technology without really having to understand how it worked. That was sort of how my introduction to WebAssembly. I was reading all of these articles and thinking, this is really cool. It seems really complicated. I wish there was a way for me to use WebAssembly without having to like learn WebAssembly. And of course, I had this idea in the shower where all great ideas come from. But the part that I want to dig into is the like an image part. That part I think is interesting. I want to tell you some fun facts about images. Images are sort of just a bag of bytes that the web page requests. If you like look at the HTTP request, it's just the image in binary. You don't know really what that image is going to be or look like. But once the request completes, the browser knows how to do something with those bytes. It can code the JPEG or PNG and display it on the screen. Images are best served from a CDN since they don't update often, and because you want that initial load to be really fast. And you can do a lot of pre-processing to images, like changing file type, resizing them, compressing them to make that loading as performant as possible. And this one's kind of obvious, but using an image on a website improves the experience of using the website. They discovered that one in like 1993. And the big secret here is that I'm not really talking about images. I am, but these things can also apply to search indexes as well if you treat your search index as an external resource that transmits information. Not all search indexes, the ones that I'm talking about for the small, infrequently updated website use case. So these static pre-generated search indexes for small sites that don't update often. So many months later, I had completed sort of the first version of what was Stork. And this is the demo that I have on the website. I really just screen recorded it. So the search result resolution is really this fast. But you feed all of your content into a command line tool, and it will generate a search index file, which, like an image, is just a bag of bytes. And then there's a WebAssembly library that you load through JavaScript that knows how to parse these index files and turns basically a dumb input tag into this sort of rich, interactive search as you type, knows about prefixes, can handle keyboard input kind of experience. And what's been really cool is that I built this as an open source project. I sort of want to keep it as an open source project. And because of that, it's the open source project that I wish had existed when I started out. And so I can run this project the way that I think it should be run. So I publish the roadmap publicly, for example. I add humanity to the documentation. I think in the footer of every page on the site, it says something like, "My name is James. I'm really excited that you're here. Thank you for checking this out." And the feature development mentality that I am able to take follows documentation-driven development principles. I think the user experience of this kind of thing is paramount. That's why I built it, because I wasn't finding a user experience that was good enough. So when I want to build a new feature, the first thing I'll do is usually write the documentation and figure out how I feel like it should work, how I would want to explain it to somebody else. And then based on what I've written in the documentation, that's what I'll go out and build. That's been sort of the most, that's given me the most reward for the amount of effort that I put in for determining how a new feature really gets implemented. This is a fun GIF to look at. I could look at it all day, but I won't subject all of you to that. Let's build an index loaded onto a page. And this demo is going to be a little bit contrived, mostly because I didn't want to have to deal with like screen sharing my own file system and dealing with the terms. So I rebuilt it all in Keynote.
James, just a question from Brian.
Yeah.
What sorts of content can you feed to the indexer? HTML, Markdown?
Yes, and plain text files. And for one person who is interested in this, I built support for subtitle files, so .srts. And if you feed it SRTs, it'll do something really cool where you can search for, this is a demo on the SRT documentation page. It's a little buried in the website, but you can search for through like YouTube transcripts and click on a result, and it will take you to the point in the YouTube video where they say that. So I think the example that I have is a bunch of 3 blue, 1 brown videos. The guy who does math animations, I'm seeing some nods. You're all a bunch of nerds. And so you can search for like second derivative and click on it, and it'll go right to the point in the video where he says second derivative, which was really cool to build. But so, yeah, that's sort of, go for it.
So basically anything that you can turn into a textual format.
Yeah. With a little bit of, you can add metadata in there like the subtitle things do. And right now it is plain text, HTML, Markdown, and SRT files. But I like, one of the goals is I'll talk about this later, but making it accessible for people who want to bring their content in whatever form. So those were sort of the 4 biggest ones that I saw right off the bat, but I'm always looking for more ways people can funnel their content into the indexer.
One more question that probably makes sense to answer now from Dima, aka Carly Koss, who's going to be speaking later this month, actually, or later next month. Is it aware of anchors? So you could jump to the closest ID element, for instance.
It's not, but that's a good feature. I haven't, there's some stuff like if you want to hook into more like specific HTML things, I think somebody else suggested like indexing the alt text of an image rather than just skipping over images entirely. Stork doesn't do that either right now, but that's a fantastic suggestion. I will probably work on that next because I really like it.
Awesome. Take it away.
Cool. So this is a little bit of a contrived demo, but we'll sort of get there in the end. Let's imagine we have a static site that we publish, and part of that is having a folder of blog posts, and they're all just a bunch of HTML files. These, I think, are titles of kotkey.org blog posts that I put together one day. And if I wanted to build a search index for my blog, then the first thing I would do is build a config file that I can pass into the indexer. And this config file will, among other things, map a file on disk, this HTML file, to the URL that will ultimately get linked to online. Once you put together your config file, you sort of open up your terminal and you can run the Stork build command, Stork, the command line tool. And that will take in your config file and generate the this index file, which again, just a bag of bytes. If you open it in a hex editor, it might be kind of meaningless. And because of that, I got to make up my own file extension. So I chose .st. And that's it. That's like your index is built, and then you can upload everything to your server, represented here by CyberDuck friend. And once you have that, then you're really done. That's the search index. And the interesting part here is like what happens in the index.html page. Presumably you have a list of all of your blog posts, but this is sort of what you need to get your search index up and running. Like so you're you put an input on the page, you put a div where the output results will go. You load the Stork JavaScript library. You can self-host that if you want. You can self-host this in the WebAssembly, but I also provide a CDN for like the I want to do this as fast as possible use case. And then you register your search index. You point it to the HTML and you point it to wherever you're hosting your index file from. And that's it. I put this together in a demo, and I'm hoping that screen sharing will let me show you the demo. But I don't know if it will because it's tied to Keynote right now. Let me see if I can switch. Can you see Safari with the CodePen link? Cool. This is the same HTML that I just showed you in Keynote, but now it's real. The CSS doesn't matter. I just wanted it to not butt up against the edges of the screen. But like, so I didn't index a bunch of Kotkey blog posts. This is this index file that comes from my own blog. And so we can search for the things that I've written about. So I wrote about my Synology NAS a while ago, and you can search for that. We can look at how many times I've written about Stork, and the answer is 1. We can look at how many times I've written about Bowdoin, which is the school that I went to. And the answer is more than 1. But this is sort of the MVP, the smallest possible thing that you need to get going. So now that we've built our index and loaded it onto our web page, that's sort of the whole of the fast version of the Stork demo. I'm happy to take questions if anyone has them.
Awesome. So I think, yeah, let's give that some jazz hands. I really like the preamble to this as well, which really helps understand, like, look, this is what you're dealing with. You don't want to run a search server. Really, you want this integrated. And as we're seeing, I think there's some really interesting things like, yeah, Dima was saying, like, yeah, if you do anchor tags, super helpful for the sort of like digital garden, second brain kind of stuff as well, where all of a sudden what you get into is tweaking relevance. Are you doing anything with that? It doesn't feel like you have much there any knobs to twiddle on terms of relevance.
The knobs that I exposed today, so I have some sort of homebrew scoring system that's mostly, and this will make a little bit more sense when I get into the slides about the data structure of the index file. But the knobs are really like, if I search for something, I want the most relevant results to come up. And I think the only real customization that I expose is how much should it weight the presence of that query in the title of your document. So you can choose like, that should matter a little bit, or it should matter a lot. And I think that's the only, I'm trying to think if there are any of the scoring knobs that I really expose.
I mean, search is such a rich area. You've got it. You know, I'm going to assume like PR's welcome. Like,
oh yeah, no, of course, for sure.
Amazing. Yeah, I mean, I really just want to highlight again. I think that was really great of you just basically going through of like, and then you're done, and this works, and you've got self-hosted search, and it's fast and gives good results. Like, yeah. Woot.
Yeah. Yeah. No, it's and like, so I built this, and then I was like, oh, now that I've built this, I can put it on my own blog, and the process of doing that sort of exposed some rough edges, and like, I think the value here is that I built this mostly for me because it's the thing that I wanted to see, but I had an inkling that this thing could be valuable in a bunch of different scenarios. It was the thing that I wanted, but I suspected it was the thing that a lot of other people might want as well. So yeah, I if no one else has any other questions or thoughts.
I have a quick question.
Yeah, go for it.
How big do the WASM modules get? And I'm guessing that the size increases linearly with how much it's indexing.
The size, I haven't done too many like hard benchmarks on this, just because I haven't gotten around to it yet. But I would imagine the size increases with the number of unique words in the corpus. That's sort of the closest thing to linear increase. The index file itself actually holds all of the contents of all of the documents so that it can do that that excerpt displaying, and that's something that I want to be able to let you disable if you're not interested in that. But the main data structure, and I'll show this in a bit, really revolves around like every unique word maps to all of the results that word can be. So if you have a lot of unique words, then that will sort of be the driver of your index file getting big. This is the table that I publish every time I publish a new version of Stork, just to make sure that the WebAssembly and the JavaScript aren't getting too big. They're a little chunky right now, and of course, I'm always trying to drive the file sizes down. But this is what that looks. Do you have? I forget if you asked anything more specific about WASM blob sizes.
Yeah, just I mean, yeah, you answered my question, just how big it got.
Yeah.
Yeah, I mean, that's really not bad. That's like a large image on your screen.
Yeah, that's sort of how I tend to think of it. If you're willing to load like 2 big-ish images on your site, then you get this very nice search experience, and for some people that's absolutely worth it.
Mm-hmm. Cool.
And you could do all sorts of other things. So, for instance, aggressive caching, or maybe in some sort of service worker or other things like that, so it sticks around pretty persistently, or have a dedicated search page that you actually go to. Lots of different areas that really come down to what are you serving up.
Yeah. One thing that I'm thinking about more recently is how I could split up the search index into sort of the small version, which is what 80% of searches will be for, and then the large version, which is like, if you really want to search something that no one else is searching, then let's make an extra web request because you deserve that.
Yeah, or the search version that's on every single page, and then the advanced search page that you're going to get into other stuff.
Yeah, exactly.
Awesome.
Any other questions, thoughts?
Go for it. Keep going.
All right.
We're waiting with bated breath for the next item.
Hopefully not too baited. Let me get back to keynote. Yeah, so let's talk about how it works. I think I mentioned this. It's mostly written in Rust. Of the 2 languages that I really heard in the zeitgeist of WebAssembly, Rust and Go. I was more interested in poking at Rust when I started Stork. Stork is actually the first like big, more than 1 file Rust project that I've worked on, which has been certainly a very good way of learning a programming language is building a big project in it. But it's the core is in Rust. It compiles both to the command line tool and to the WebAssembly blob. And then there's a smallish JavaScript shim. It really doesn't feel like 20% of the like feeling of Stork. It feels like most of the feeling of Stork is Rust. But that JavaScript shim is the thing that web developers actually interact with. It handles loading the WebAssembly, loading the index, and attaching to the DOM to make the DOM interactive. There are other languages in there that GitHub likes to show, but Rust and TypeScript are the 2 biggies. This is the like 30,000 foot view of the Stork architecture, and I like to start talking about the API. That's what both the command line tool and the WebAssembly interact with. And the API is built on some really generic shared models. So there's a model for like a generic result that will get passed up to the WebAssembly. There's a very generic query kind of model. And those can basically never change. Because one of the things that I care a lot about for is backwards compatibility with Stork. If you build an index today, even if I update the index version, the schema behind the index file type, that should still keep working if you want it to in the JavaScript libraries that I publish from now on. So once you have your shared models, you can have the v2 index version and the v3 index version that both conform to those. And each index version has a builder module and a searcher module. And this has been sort of a very scalable way of building it. It lets me, if I need to change how the indexer works, it lets me do so without breaking everything, which is kind of nice. Yeah, and so on top of the API, there's the command line tool that's adding a lot more code to handle like nice terminal interactions and things like that. None of that needs to get compiled into the WebAssembly. So it lives off in its own little world. And then none of the WebAssembly stuff needs to get compiled into the command line tool. So that also lives off in its own little.
Maybe a good time to ask this question. Philip asks, can you compile what the command line tool does to WASM? So basically, can you generate an index within a browser for actually running this online?
Oh, that's a slightly different question than where I thought you were going. I'll answer that, and then I'll answer the question that I thought you were going to ask. So there was a hard dependency on the file system for a while, and I've actually been doing some development streaming on Twitch. And one of the features that we recently built on Twitch was you don't have to point the indexer at a file anymore. You can point it at a web page, and it will fetch the web page and index that web page. So there's no more dependency on the file system if you don't want there to be. But I haven't taken the time after that to say, like, now the indexer can be compiled into WebAssembly. I've honestly never tried it. I don't think it's possible.
Yeah, depending on how it is, depending on how it's done with file system stuff and so on. This is very much a Fission team question because we run everything client side, and we're very interested in doing more work with WASM, and we have essentially a web attached file system. Yeah. So we're interested in making as much of this as possible. So Philip is saying, I was hoping for the Fission Stork indexer app. And it's like, well, again, PR's welcome, Philip.
For sure. No, the way that I use WebAssembly is sort of probably one of the simpler ways of using it. I see it as I'm exposing a pure function to you in which you take in two inputs, an index file and a query, and it outputs stuff from the shared models, just a list of results. And the JavaScript knows what to do with that list. But a pure function is sort of, that seems like the simple use case of WebAssembly. And the reason I'm using WebAssembly at all for that is because it's just going to be blazing fast to parse this index file and to run that lookup compared to the question that I thought you were going to ask is, can you turn the index itself into a WebAssembly blob? So instead of loading the Stork WebAssembly and then loading the index on top of that, just having one thing that gets loaded that sort of hard codes the application logic and the indexing content together. And that's also something I've been looking into but haven't gotten around to yet. I'm thinking of sort of how to portray that use case as different or better, or when you would want to use that. But that's sort of something that's always rolling around in the back of my head. I guess to tee up that next slide, I want to talk to you about the index version, because I think that will answer maybe some questions. Maybe it'll just introduce more questions, but it might answer some questions about like what's actually going on under the hood when you're indexing content and searching for it. This took about a week to design. I would like look at it and stare at it and be like, how is this going to fail on me? And I would tweak some things, but this is the actual diagram that I put together when I was designing this version of the index. Anything in this, let's see, this serif font is annotations that I've added for this presentation. But the index is a serialized Rust struct. I use some serializer that makes it really small, but also where I can add fields, and that won't break everything. There are some serializers that I use where that would just make everything fall apart, which was a bummer because it means the indexes are bigger than they could have been. I saw a small index for a bit and it was good, and then I added a field to my struct and it didn't work. But the index file, like I said before, it contains all of the contents of every entry, every document that you've indexed, has some metadata about that. But the real bulk of it is this basically big hash map lookup table for queries and results. And a query, you can't compute every single entire search query that someone is going to search for. So I segment it by word. And every unique word in your corpus becomes one of these queries. And a query will map to multiple results or multiple aliases. And aliases are how I deal with prefixes and stems. So if you search for weighting, that will be an alias for weight, or weighted, and that will go back and resolve one layer down and go back to the query and get you all of the results for weighted instead. There's a lot of deduplication and combination to go from like these are the words to these are the results to these are the excerpts that I should display. You can imagine if you search for 3 different words and they're all right next to each other, you want to just turn that into one excerpt that gets shown in the DOM. But then once you've searched for, once you've done that deduplication and combination, then it'll output a bunch of output results, which are part of the very generic shared models layer of things. And then this is sort of the purview of the JavaScript layer on top. And I wanted to talk just a little bit about the challenges there. I said this earlier, the JavaScript is responsible for loading the WebAssembly, loading the index, and then sometimes you don't have to use this, but harnessing the DOM. You can use Stork in a way where you're just calling a JavaScript API if you want, not touching the DOM at all. These are asynchronous operations that can complete at any time or fail. And I sort of had to draw this out to really figure out what all of the failure cases could be. But I make you start each of these operations in this order, which sort of simplifies the first half of the equation for me. But there will be a point before this red line where the DOM has been harnessed and nothing is ready to search yet. And I display a loading bar if you want that. And I will actively prevent WebAssembly from trying to do its thing because that results in some scary errors. But then after that line, after the WebAssembly is loaded and the index is downloaded and the index has been loaded into the WebAssembly memory space and parsed correctly, that's when search can resolve and be interactive, and the DOM sort of switches modes and we'll take what you type and resolve it into this. Stork is, I've been working on it for a year. I still treat it as like a baby project. I like the list of stuff I've done is so much smaller than the list of stuff that I want to do or that I could envision. And so I'm really excited about where Stork is going and I don't know, just like the opportunity that I get to have to continue working on it. So I don't know what Stork is going to be like in the far future, but I have a sort of idea for the next year plus. I want it to sort of bubble up as the obvious choice for search if you're building a static-ish site, a site like a blog, a site like this college newspaper website. But it could be a strong contender in other situations too. I had talked to someone who was building a SaaS product and was interested in building one search index per user and keeping that in sort of whatever private file system they wanted, and then letting users search for their own content without being able to search through the entire content of their application. the skate to where the puck is going analogy really means like this should be something that other people want to use, that they can take advantage of. And I want to keep on top of like where people are struggling with search, what web technologies I could take advantage of to make Stork extremely usable, extremely performant. And so I've been working a lot with Next.js to make the Next.js plus Stork pathway very frictionless. A coworker of mine, Johnny Hallman, has written a lot about the idea of a lifetime project, and that's sort of something where it's a project that I'm not trying to like ship as fast as I can or get to an MVP as fast as I can. Like this is something that I want to work on for several years, if not a lifetime. And I want to design it with that in mind. So the longevity of Stork is something that's really important to me. And I try to maintain the roadmap and publish it online so people can look at that page and know that Stork is still being worked on and know if Stork will end up being the right kind of project for them, or they can evaluate it and say, this isn't what I'm looking for. I want something that's different for these reasons. I want to go back to that Google custom search iframe. I'm going to determine that Stork is not for me. And so, yeah, I'm really excited about where Stork is going, getting to show it to the web development community, getting to show it to people who are interested in using it, and building something for myself, for others, that can, I don't know, make the web publishing experience nicer for everyone to use. So that's been me. This is where you can find me. This is where you can find Stork. I am more than happy to chat more about this if anyone has questions or thoughts or feature suggestions. Thank you for coming out and listening to me talk about Stork. I'm really excited to get the opportunity.
This is great. Thank you so much. Round of applause. Absolutely. Yeah, really great. There's lots to start with here. I think it's really interesting when you reset those sorts of things and start saying, wait, personal search is totally possible, not just possible, but can be great, and then build from there. One of the things that I've been seeing, and I hang out, and a lot of the Fission team does as well, and people who are thinking lots about decentralization and self-hosting and user agency, that whole like search and index per user is super interesting. Like that is not a typical use case. I can't actually think of something like that. Like for me, I immediately want to think about something that is tuned. Dima was mentioning searching your own digital brain. And that is the closest to something like that. But that gets me immediately to doing things like, while we're at it, let's do a full text crawl of everything that I link to. Right. So that's super interesting. And then the other thing that I've been seeing is local search. So very roughly related, people putting together web rings of personal websites. I'll use that use case initially, and then wanting to search over them. So that immediately makes me think about aggregated indexes. Yeah, I mean, there's a million things you can go for. Search on the internet and search generally is kind of a big problem.
It's a big topic, yeah, which is part of why I can sort of see this as a lifetime project. There's so much in the space and so much that like ways that search and content are going to interact that we haven't really thought of yet. And I don't know, I think Stork can be there for it.
I think one thing that really leaps out at me is I've also been thinking a lot about the tensions between the content web and the app web. This, as presented today, is on the side of the content web, or is a progressive feature that really increases the experience of the content web. But in even its tool chain of using WebAssembly and some other stuff like that, it probably has a lot of commonality with the app web.
Yeah.
Have you given some thought to those tensions and how you think about that?
I think I'm still solving for because yeah, no, definitely. Like, I think in the like about me slide, I said something about how I'm interested in the web as a documented application publishing platform. And even like I was writing that slide and feeling that same tension. How do I address all of the things that the web can be and the fuzziness between those two things? I have only been thinking about Stork in terms of the content web, just because I think there's still more to do there, and the application web turns into something sort of more complicated. But yeah, no, it's totally the two can interact, and I think Stork could be a good contender in both spaces.
Jack, other than applause, do you have a question there that you want to say?
Thank you. It's my first time using the raise hand feature. It's super. Well, sorry to pull back from like the grander discussions, but is it possible to speak briefly to how stemming works? Is that a word? Stemming?
Yeah. I sort of outsource it to a Rust crate that uses the snowball stem algorithm, which is an algorithm that I don't think it like uses some basic linguistic knowledge of a bunch of different, mostly Western languages to go from word to root, and none of the roots are actual words. And so I'm doing the same thing actually on the client side. As you search, the aliases are not all of the different options that you get from a stem, but I'm searching both. I'm searching the word itself and the stem of the word to resolve those stemming differences. But yeah, I guess the answer to the question that you actually asked is there is already a Rust crate out there that you give it a word and a language, and it will get you its stem. And I take advantage of that.
Cool. I can look into the snowball algorithm. Sounds pretty cool.
Yeah.
Thank you.
I think that's a really interesting question for me as well, when I talked about tuning it and so on. Can you maybe talk about right now about how you think about whether a feature makes sense for Stork?
Yeah, I can talk more broadly. I think the documentation-driven development aspect sort of helps there. I'm wondering if there's a question behind the question, something more specific.
This is the classic open source thing, right? So right now you're the primary maintainer.
Yeah.
Random people might do a PR. Random people might ask for features. I'm literally in there's a big discussion, and we're looking a lot at how to support digital creators in building, maintaining apps, right? So you have the great luxury to have this as a fun side project, which is amazing. And then the question becomes really how do other people interact with that, and where does the James vision come in of saying this is not a fit because I think of it like Y.
Yeah. I think to answer that, I go back because I struggle with that. This is the first open source project that I've really shepherded, and I'm kind of figuring that out as I go. How much do I want to like put down railroad tracks and make sure that everyone who's contributing is moving in the same direction, versus how much do I want to go with the flow and let people add in whatever patch they want, even if it's not something that I had envisioned or thought of, or even if it's something that I think goes slightly against what I imagine Stork to be. So yeah, it is something that I have a little bit of a tricky time with, and an example that I'll talk about is self-hosting the JavaScript and the WebAssembly. That was not something that I supported in the beginning. The whole tenet was you shouldn't have to think about WebAssembly. You should just load up this JavaScript from my CDN, and I'll deal with that for you. And I heard pretty quickly, once you get past like users of a certain size, usually people don't like that. They want to make sure that the resources are coming from their own CDN, or at least just being hosted from the same domain because of like browser fastness issues that I don't quite have the words to describe. And so I had back and forths with people who were saying like that Stork is for me, except this the fact that you can't self-host it is a complete deal breaker. And I thought about, I went back to sort of the tenets of the project that I think about, which is like, it should be the search solution for people who are building websites, like whatever kind of website they're building. And I want to be open to people's use cases. And so I spent time building self-hosted Stork, and I had to re-architect a lot of the JavaScript module, especially to allow for like, this WebAssembly isn't coming from my CDN, it's coming from wherever, and you might not actually be feeding it this valid WebAssembly blob. You might be trying to stick garbage in my library, and how do you deal with that? Ultimately, it's about trying to understand how to best serve the people who are using Stork. Yeah, thank you. How to best serve the people who are using Stork, and make the experience the one that they can work the fastest and the smoothest and the most predictably with.
That's a really great answer with some good insight in there, right? I mean, there is no one answer. You know, I think that's also like, potentially those are good problems to have in the sense of of what you want in terms of types of users you want to serve, or the tensions of, see, well, you know, I want to build on top of it and go in this direction. And it's like, cool. And then you start getting into questions of, do you make the architecture even more modular? And maybe Jack wants to take out the snowball crate and add a different one that has specialized stemming, or Brian's going to add something for searching music notation, right, Brian? Awesome. Yeah, this is very, very interesting. You know, at Fission, we're doing lots of things in the front end, so this really caught my eye. And obviously, Brian at Begin with his serverless mode. You know, I actually immediately think of this as something that we could add to a GitHub action. So we've got a publish action at Fission, and it's the type of thing that you could potentially run there. I mean, a lot of the stuff that we do, we're doing builds and deploys directly from our personal desktops. You don't need to use Git at all to publish to Fission. And I think that fits the Stork ethos really nicely, because you just run it all as part of your build pipeline, right?
There's a guide on the documentation site for doing that with Netlify, how to publish. I think I built my own website with 11D and Netlify, and once I figured out how to get search working on my site, I was like, this can be something that everyone can know how to do. And so the guide is like, if you're using Netlify, if you're using 11D, here's how to index your content and generate a new Stork index whenever you publish your site. So absolutely.
Do you see any issues with like cross-site, or how do you think about other standards? So I think there's an open search format. I need to look at it again. Discourse, the forum software, supports it, where yeah, I'll look at it later, and I'll post or tweet at you about it.
The answer is I have not thought about that. That isn't something that I think I didn't know that existed. So
I think there's an endpoint where you can basically, if you expose the right metadata on your site, then it makes it easier right in the URL bar to do sub-site search, basically. So I think that literally might be the sort of thing that you can like literally just add some metadata.
I'm clicking on the link in chat to see if
There
I
you
can
go.
speak to this in 20
Got you.
seconds.
Dima, what are you thinking of? Tell us what you're thinking.
I was just saying, I mean, imagine if it was a bookmarklet or something, so you could run it against any page, and maybe even like imagine you're browsing someone's blog, like retrieving the whole blog is you know what's 10 megabytes of simple JavaScript scraping would be enough. So you could have like search across someone who hasn't set up a search. So
That's a wild idea. I hadn't thought about that at all, but that would be really.
it's like, yeah, I mean, I guess in principle you can use, you know, Google or something, but not everything's indexed, and yeah.
That is really interesting. I mean, yeah, I mean, that's kind of what I was thinking about with neighbor search, is that if you get a significant number of people indexing their own content, including tweet that the way that their opinions are, right? And then you combine those together. Yeah, there's probably some interesting, like, we're pretty far away from what Stork does, but there ends up being some really interesting things there that are very different than how we think about web search engines today. Right?
Yeah,
like
I mean,
most
private web service, you know, I wish there was somehow there is no, so I wish I could run my private indexer against a bunch of websites or like GitHub repositories. The closest I have is like a script which pulls few Git repositories, and then I can run ripgrep, which is instantaneous anyway, but it's also nice to have some ranking and you know, a browser interface. And again, like closest I have is Emacs with you know, Helm or whatever, which is, you know, it's nice, but yeah.
You're among friends here.
Yep. This is a safe space.
The part where
actually sort of related, I had a question. Have you thought about doing like, I don't know if you've ever used the Dash app for Mac OS, but like documentation search, right? Like this seems like it would be perfect for, yeah, grab a bunch of documentation files, build your Stork index, and then you have, yeah, sort of an alternate offline accessible version.
Yeah, the offline sort of aspect isn't one that I had thought of. Again, it would be not difficult to spit. Like Stork has a test mode where you can like test out your config file and see if it works for you, and that sort of just spins up a local web server and runs basically the code pen that I showed you earlier with the index that it could create. And documentation, I sort of bundle into that same category of, it's a static site. The content is like small enough to fit in a Stork index. It's not going to update often, and you could like, I don't know. I think about the Stripe documentation too much because I work there, but like you could
It is some of the best documentation out there, though.
It's
like,
pretty good, I think, and props to the teams who work on that.
Yeah.
But you could imagine something that that loads all of the Stripe documentation every day at midnight and builds your own little offline Stripe docs search.
Right. So related questions, like, have you had any discussions internally at Stripe to use Stork to replace the search? No.
Just for my own sanity, I really want to sequester the two.
this is a side project.
So related then, are you still in touch with anybody at Bowdoin? Because I noticed they're still using the Google iframe for the paper.
Yeah. I mean, I chat with the people who maintain the website today, and haven't, like, the ideal state would be like some WordPress plugin, and this is like internals of this website that I designed 4 years ago, which is not the best presentation topic, but like the way that we do co-authors is really weird, and I don't think it would be super easy to extract that data structure into something that Stork could know about. But in fact, one of the pieces of content that I used when I was testing and developing like index pages from the internet is a bunch of Bowdoin Orient newspaper web pages, and you could imagine like an index file that lists off all of this year's articles that got written and fetches them from the website and loads them. Yeah, so I think just to the way that development process is going, I would have to sort of make a drive-by PR against this website that I don't really maintain anymore, which
this brings up actually an interesting choice. We've got a couple of projects where we're experimenting with Headless. So one project's going to be Headless Wordpress. Helder on the call has done a big tutorial about how using Fission with Headless Ghost, and our own blog is Ghost and going to go headless. So this is a great use case for looking at how to put that in there, which is you just make that part of the build step and it should just work, right?
Yeah.
When we say make it part of the build step, do you have some information and tooling on how to, like, I don't even want to mention the 9 billion different bundlers and builders and so on. What do you use personally as you use 11D?
I use 11D, and I this might not be the answer that you were hoping for, but I keep the Stork stuff pretty out of band of the 11D build process. Right. So instead of like having my build script just call 11D build, I've built a little shell script that will call 11D build. 11D is putting together the config file, so it's looping through every blog post that I've written, putting that index, that config file together. And then after that, I wget the binary, make it executable, execute it, and then I have the index file in my output completely separately from the 11D build process.
What?
let me pull up the documentation, or at least
the part where you wget the binary and make it executable was the part where I'm like, so you're grabbing the WASM blob.
Let me stick this docs page in the chat. Okay. And step 2 is my build script, where I get the binary from.
The Stork CLI is the binary you're talking about, right?
Yes.
Okay.
Yes.
Okay, right. So because you're doing this, on
11D's, on Netlify's task runner.
Like Netlify, right? This is the part where it didn't make sense to me, because I'm like, if you're building locally, what? So the local version of this would literally just be
the repository has markdown files for all of my blog posts and a template for the config. And then the 11D build process will untemplatize the config, make it a full Stork config. And then I run the command line builder on that config and just stick an index file in the output and let Netlify serve that.
Right. And you're kind of just reading this guide as well that I've clicked through here. You're kind of doing this next steps at the bottom is you prompting for people to think about how this all works and how they might change it.
Yeah.
Great. Yeah. Awesome. Like the next prompts that some people may be asking in their brain already, or leading towards those things, which is really awesome. Okay, we are at about 10 minutes after. Does anyone else have live questions they want to ask, big or small, of James? Awesome. I am going to hit the stop recording button after we do one more thank you on camera. Thank you so much, James. That was super fantastic.
Thank you for having me. I'm so thrilled to be here and really grateful to get to chat with all of you.
Awesome.